this video, we are going to learn about breadth first search algorithm. BFS travel tree level wise. It is implemented using queue. We will learn how that queue will be implemented. So no backtracking is required. Just like DFS, in BFS no backtracking will require. In DFS, we see in our previous video that backtracking is required in DFS. So BFS never get trapped into infinite loop. In DFS, it will access all the child nodes of it. So because of that, infinite loop will be it will trap into infinite loop. But in this BFS, no infinite loop is there because it travels level wise. Okay, so we will understand this BFS concept using this image, so you can easily understand how BFS work. Just I say before that BFS travel level wise. So it will access node A, then it will goes towards B, then it's a neighboring element like C. So first level is completed. Then it will goes towards second level. It will access D, E, F, G. So this concept is implemented in BFS. So what is queue and how it will implemented? So we know that queue is first in first out. So just like this, first A is stored in queue just like A. Then when A is removed from queue, it will go to its neighboring nodes like child nodes of A, B and C. So B and C is stored here. So after that, when B is removed, then D and E will be stored. Okay, when C is removed, then F and G and so on. This concept is implemented in this BFS. So let's understand this code. First of all, we define that our graph looks like this. A node have its child node B and C, B has D and E, C has F and G. So as you can see in this image, A has B and C as child node, B has D and E, C has F and G, and this D, E, F, G will not have any child node, so that's why we give here empty. So why this written in our code, like why we use this visited and queue variables here. So visited and queue is using for storing nodes. Visited is used for storing nodes that are visited in these loops, and in queue this image I given to you, this queue like structure is stored in queue variable. So this is the uh, so in this, visited graph and node are the parameters given for this function. So in visited, we will store values or nodes that are visited. In graph, this data is stored, and node, this node contain which node is currently executing. So using these two lines, we can store that nodes in this variable. So visited dot append node, it will store currently visited node, and in queue it is stored. So this while loop perform the main function in this BFS algorithm. So while queue, in this we define a variable in this queue.pop. In queue we have the nodes which are stored in sequence. So queue will what pop in this queue, the node which is present outside means first node which is present in queue, this node is stored in m variable, and this m variable is printed using this print function. And why we use this? Because we want all the nodes to be present in one line. So after that we will check that we give here that or call our function here. So here we give a node A. So this node A will store in visited and queue, then it will go towards here. So queue will pop that first node which is present in that list. So it will store in M, then it will print that node A, then it will check that for neighbor in a graph M. So M value is A. So it will check that A has neighbors, then if A has neighbors, then if neighbor not in visited, it will check that A's neighbor like B and C is not present in visited list. So if A nodes are not present in this visited list, so it will append this. Like it will check that A has B and C, but it will, if they are not present in that visited and queue, so it will store this B node in visited and queue. So this process is implemented here. So when we run this code, it will give us this output like A, B, C, D, E, F, G. So we can also see here like A, B, C, D, E, F, and G.